On this video, I like to talk about inverse cosine. So when you look at the graph of cosine x, again, this is not one-to-one function, meaning that it does not pass horizontal line test. However, if we kind of zoom in from 0 to pi, now this graph from 0 to pi becomes one-to-one, which means you could have inverse. And when you graph the inverse of cosine, again, we could use that, or we could use arc cosine of x. These two are the same thing. When you graph that, again, the domain of cosine, which is 0 to pi, becomes the range. So 0 to pi. Okay, now, and then the range, which is -1 to 1, becomes the domain of the inverse. And when you graph it, it will look something like this. Okay. Something like that. That's the graph. Now look at the restriction. Now, whenever you evaluate inverse of cosine, the restriction is from 0 to pi. Now let's look at some example. Let's say they want you to evaluate. They want you to evaluate inverse cosine of negative radical 2 over 2. Again, this is some data, okay? So basically, we're looking for cosine of theta is equal to negative radical 2 over 2. Again, you have to understand the restriction when you talk about inverse cosine. Whatever you get, it has to be from 0 to pi, including the endpoints, meaning that the angles are either first or second quadrant. Now, you know that cosine theta is negative in the second quadrant, okay? First of all, cosine of what is radical 2? Well, cosine of pi over 4. Or if you want to talk about degree, it'll be 45. But that is the reference angle. What you want is you want the angle of this. Since cosine theta is negative. Well, that's going to be pi minus pi over 4, which is going to be 3 pi over 4. So cosine of 3 pi over 4 will be negative radical 2 over 2. Now let's check. Is 3 pi over 4 within the restriction? It is. Therefore, the answer is 3 pi over 4. Now let's take a look at another example. This time we're going to look at arc cosine of -2. Arc cosine of -2. Now this means, again, this whole thing represents some theta, meaning that cosine of theta, cosine of which theta will be -2. Now let's think about this. If you look at the graph of cosine theta, the highest that it goes up to is 1. and the lowest value, y value, it goes down to its -1. So is there any case when cosine theta is ever equal to -1? Well, the answer is no. So what's the answer to this solution problem? Does not exist. Let's look at our final example. Let's say you got inverse cosine of 0. Again, this whole thing represents some theta such that cosine of theta is 0. Now, cosine of what is 0? Well, cosine of pi over 2 is 0. And cosine of 3 pi over 2 is 0. These two are both correct. However, again, we're dealing with inverse. What's the restriction? 0 to pi. Unfortunately, 3 pi over 2 is not within the restrictions. So the only answer is theta equals pi over 2.